Hello, welcome to SPMM Revision on Demand. In this podcast, I will discuss the concept of hypothesis testing and the issue of type 1 and type 2 errors. Research is all about making an observation in a sample and then generalizing the observed result to the larger population. This is the process of deduction or making inferences. But there is a limit to what can be deduced from a sample. Let's say you want to prove all dogs can bark. How many dogs do you need to assemble to prove this? You probably need all dogs on the earth to prove this. You simply can't get the time and money to test this hypothesis. Scientists get around this problem by creating a null and an alternate to null statement. The obvious opposite of what you want to prove is called the null hypothesis. So if you disprove this opposite statement, you are adding credence to the original supposition, which is known as the original or alternate hypothesis. Thus, science proceeds by falsification, not verification. This notion was made popular by Karl Popper, a philosopher. In summary, to enable the process of deduction, we need to formulate testable hypotheses and the null form. To recap on this concept, look at this table. What the researcher believes and wants to prove, that is the original research question, is called the alternate hypothesis. What the researcher sets out to disprove is the null hypothesis. In this case, some dogs do not bark is the null hypothesis. You can easily disprove this by assembling a reasonable sample of dogs and show that all of them bark. When you assemble a sample and test for the presence of an anticipated difference between two groups, you have two possible outcomes. You may either see a difference in your sample or you do not. But your sample need not always agree with the universal truth in the whole population. In reality, there are two possibilities. Either there is a true difference as shown in this figure, or there is none. This is now plotted in the table shown here. The sample level conclusion is presented as two rows. You finding a difference or are you not? The universal truth is presented in two columns. In reality, is there a true difference or is there not? Now let us consider in detail the situations when the rows meet the columns. There are two places where the study results are in disagreement with the universal truth. These are circled here. As the universal truth is the ultimate reality, let us call these disagreements as errors in a study. So there are two types of errors, type 1 error and type 2 error. When the universal truth suggests that there is no difference, but your study in the sample ends up finding a difference that doesn't really exist, this error is called type 1 error. Almost all researchers would want to keep this error rate low. That is, less than 5% is the acceptable threshold in most scientific disciplines. The type 1 error rate is also called p-value or significance level. When the universal truth suggests that there is a notable difference, but if your study fails to find it, this error, an error of omission, is called type 2 error. 20% is the maximum acceptable level of type 2 error in most studies. The complement of type 1 error rate, 5%, is 1 minus 5%, which is 95%. This gives us the confidence level associated with study results when a p-value of 5% is chosen. The complement of type 2 error rate, 20%, is 80%. This gives us the power associated with a steady. So remember, 80% for power and 95% for confidence level. This corresponds to 5% for p-value and 20% for type 2 error. Now in this figure, I will try to illustrate type 1 and type 2 error using cartoons. The figure on the left tells you what it means to commit a type 1 error. You see someone with no rashes, but you conclude that they are full of rashes. You observe a difference when in truth there is no difference. This is type 1 error. This is an error of omission. In type 2 error, you see a man full of rashes, but you declare that he is fine and he does not have any. So you are missing something which is obvious. You're failing to observe a difference when there is a difference. This is type 2 error. This is an error of omission. Now, p-value, p is the probability of falsely rejecting null hypothesis, or the chance of a positive result being spurious. The lower the p-value is, the better it is. If p is equal to 0.01, the risk that a result observed in a study is due to chance is 1 in 100. If it is 0.05, the risk is 5 in 100 or 1 in 20, the level that is commonly accepted by the scientific community. Please remember, multiple testing increases type 1 error. Think of throwing a dice 100 times. You will have at least some sixes. So if you use a single data set to test multiple different hypotheses, it's likely that you will find at least one hypothesis, one null hypothesis rejected. And this may be purely because of chance, not because of the truth. Now, power. Power is the ability to find a difference if the difference truly exists. It is the probability of rejecting an incorrect null hypothesis. Higher the power, better it is. Lack of sufficient sample size is the most common reason for reduced power. Type 2 error relates to small samples. High variance of the measured outcome also reduces power. Now it's time to ask yourself a few questions. Thank you for choosing SPMM course for your revision.